All right, this is the last section for Math 140, section 13.5. It's called the Binomial Theorem. All right, so a polynomial with exactly two terms is called a binomial. Okay? In this section, we're going to develop a formula for the expression by raising a binomial to an integer power. I shouldn't say integer, I should say to a whole number power. Or basically just a power, but we're not going to do fractions and things like that. Okay, so if we look at the powers of x, or x plus y to the first power is simply x plus y. Okay, x plus y squared is this one I'll do is x squared plus 2xy plus y squared. Okay, how do we get to the third power? Well, we take this and multiply it by x plus y. Now I'm just going to do this for you. You get x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay? All right. X plus y to the fourth. I would take this and multiply by x plus y. I'm just going to give it to you. It's x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Okay? X plus y to the fifth is going to give me x to the fifth plus 5x to the fourth y plus 10x to the third y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. Okay? All right. So what do we notice about all of this stuff? Let's see, the number of terms, 1, 2, 3, 4, 5, 6. That's one more. 1, 2, 3, 4, 5. That's one more than that. 1, 2, 3, 4. It looks like the number of terms is always going to be n, where n is your exponent, is n plus 1. Okay? Each expansion has what? X and y terms. Also, the powers of x decrease and the powers of y increase. Okay, the sum of the powers of each term is what? 4 plus 1, 3 plus 2, 2 plus 3, it always equals 5, equals n. Okay, and the coefficients increase and decrease in a symmetric way. Right? All right, so for non-negative integers n and k, where n is greater than k, the symbol n of k is called the combination and is defined as this. Now, I don't want to say n over k, okay, but this would be n combination k, or n choose k. All right, the definition of this is going to be n factorial over n minus k factorial times k factorial. Not that you're going to need it, because we're going to do everything on our calculator. So let me just do a few of these. How would I do 4 choose 1? So I would go 4, and then I hit the math key, and I come over here to probability. Choice 3 is the combination. So if I do 4 choose 1, I get 4. If I do 5, choose 3, it's 5, math, come over to probability, choice 3, so it's 5, choose 3, I get 10. What is 9, choose 0? 9, math, move over to probability, choice 3, choose 0, it equals 1. 35, math, probability, choice 3, 35, choose 35 is also 1. Okay? All right, so my binomial theorem, since I have space here, let me show you, another way to do this is use Pascal's triangle. So if I'm looking for these coefficients, there's a 1 and a 1, that's the 1 and the 1. To make this next row, we go 1, 2, 1. So I start with a 1, and then I add the 2 numbers above it. And if you notice, what do I get? I got 1, 2, 1. Okay. The third row would be 1, 3, 3, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. This is called Pascal's triangle. This will also give me the coefficients that I need out in front of these expansions. So you might want to do that sometimes too if you're doing a lot of these things. Okay. All right. Now, how this corresponds to this, like this 5, choose 3, I go down to the 5th row and I start counting at 0. So this is 0, 1, 2, 3, 4, 5. So this number, excuse me, this 10 would be the 5, choose 3. Again, row 5, start counting at 0, 0, 1, 2, 3. So this 6 is 4th row, 0, 1, 2. That 6 is 4, choose 2. So that's another way to evaluate these things if, you don't have a calculator. All right, so here's your binomial theorem. A plus b to the n, okay? We're just going to start with n to the 0, n to the first, n to the second, dot, 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 all the way down to n to the n. That's how we generate these coefficients. But we also note that this is going to be a to the n power. Okay, so that's this first term to the n. Then the middle term, or the second term, is always going to be a to 1 less power, and then b to the first power. Remember, these have to add up to n. The second term is a to the n minus 2, b to the second. Third term, a to the n minus 3, b to the third. Remember, these always have to add up. So my last term, the a would be to the 0 power, I guess, and then I would have b to the n, which is why I always had y to the 5th here, y to the 4th, and so on. Okay, so how does this work? Okay, expand this using the binomial theorem. So x plus 2 to the 5th power is going to be, whoops, let me move this down a little bit. It's going to be 5 to the 0 times x to the 5th plus 5 choose 1 times x to the 4th, 2 to the 1st, plus 5 choose 2, x to the 3rd, 2 to the 2nd power, plus 5 choose 3, x to the 2nd power, 2 to the 3rd power, plus 5 choose 4, x times 2 to the 4th, plus, kind of running out of room here, 5 choose 5, x, I'll say to the 0, right? 5, 4, 3, 2, 1, 0, times 2 to the 5th power. Okay? So let me see if I can't do this a little bit. 5 choose 0 is 1. So this is 1x to the 5th. 5 choose 1 is 5 times x to the 4th times 2. 2 to the 1st power is 2. Plus 5 choose 2 is what? If we go 5, math, move over to probability. Choice 3, 5 choose 2 is 10. So this third term is 10. X cubed, 2 to the second power is 4. 5 to the third is going to be also 10. X squared, 2 to the third power is 8. Plus 5 choose 4 is 5. X to the first power. 2 to the fourth is 2, 4, 8, 16. Plus 5 to choose 5 is 1. X to 0 is 1. And then 2 to the fifth is 32. So my expansion becomes this. 1x to the fifth plus 10x to the fourth plus 40x cubed plus 80x squared plus 80x plus 32. Okay? All right, so you can see here's my symmetry with these things. 1, 5, 10, 10, 5, 1. Okay? And then I just have to know how I'm going to raise this. Okay, how about 5x minus 2 to the third power? Using a binomial theorem. So it becomes 3, n is 3, so it's 3, choose 0. 5x to the third, I'm going to say negative 2 to the 0. I'm going to write all of these things out. Plus 3, choose 1. 5x squared times negative 2 to the first power. Plus 3, choose 2 times 5x to the second power. No, excuse me, the first power. This was the second, so 3, 2, 1. And then negative 2 must be to the second power because they have to add up to 3. And then my last term is 3, choose 3, 5x to the 0, negative 2 to the third. And then we just expand on all this. 3, choose 0 is 1. 5x cubed is 125x cubed. Negative 2 to the 0 is 1. Plus 3, choose 1 is 3. 5 squared is 25x squared. Negative 2 to the first power is negative 2. Plus 3, choose 2 is 3 times 5x times 4. 3, choose 3 is 1. 5x to the 0 is 1. Negative 2 cubed is negative 8. So what do we end up with? 125x cubed plus, let's see, negative 2 times 3 is negative 6 times 125 is a negative 150x squared. So you could have minus 150 there, I suppose. 3 times 5 is 15 times 4 is 60. So this is plus 60x minus 8. And that is my expansion of 5x minus 2 cubed. All right. How about this mess? I got x to the 1/4 plus 2y square roots of y raised to the 4th. So let me just, you know what, I'm going to build this vertically here. So my first term is going to be 4 to the 0. And then I get x to the 1/4 to the 4th. Okay, and then I'd have 2 square roots of y to the 0, which is 1. So my next term is 4 choose 1. I'm going to have x to the 1/4 cubed times 2 square roots of y to the 1st. Then I get 4 choose 2, x to the 1/4 squared times 2 square roots of y squared. Remember, they have to add up to 4. 4 choose 3, I get x to the 1/4 to the 1st, 2 square roots of y cubed. 4 choose 4, x to the 1/4 to the 0, 2 square roots of y to the 4th. Okay, so let's see. 4 choose 0 is 1. X to the 1/4 raised to the 4th is just x to the first power. 4 choose 1 is 4. Let me put something underneath this. I don't like the way this is writing. So 4 choose 1 is 4. X to the 1/4 cubed is x to the 3/4 times 2 square roots of y. 4 choose 2. What is 4 choose 2? Well, let's see. 4 math probability choose 2 is 6. So I get 6. Let's see. X to the 1/4 raised to the second is 2/4. So that's 1/2. Times 2 squared is 4. The square root of y squared is y. This is symmetric. I only have 2 terms left, so 4 choose 3 must be 4. X to the 1/4, right? 1/4 to the first, times 2 cubed is 8. The square root of y cubed is, well, you know what? I'm just going to say y to the 3/2 power. Right? This is to the 1/2 power. 1/2 raised to the third is 3/2. My last term is 1 times 1. 2 to the 4th is 16. The square root of y to the 4th, square root of y to the 4th is y to the 1/2 to the 4th, which is y squared. Okay? So let's see if we can't clean this thing up a little bit. What do we get? We get x. That's my first term, just 1 times x. This is 8 x to the 3/4 times the square root of y, plus 6 times 4 is 24 x to the 1/2, which I could write as square root, times y. Okay. Plus 4 times 8 is 32 x to the 1/4, y to the 3/2. Plus 1 times 1 is 1, times 16 is 16, 16 y squared. So that's kind of a mess. But doing that by hand, I think, would be a lot more work. So, all right. Well, I hope that helps with section 13.5. That concludes the course. Good luck with your Unit 5 test and your final exam. All righty.